Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here is information about online seminars for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam P on probability. An insurance company sells automobile liability and collision insurance. Let X denote the percentage of liability policies that will be renewed at the end of their terms, and Y be the percentage of collision policies that will be renewed at the end of their terms. X and Y have a joint cumulative distribution. F of xy equals xy times x plus y divided by 2 million for x between 0 and 100 and y between 0 and 100. Calculate the probability that at least 80% of liability policies and 80% of collision policies will be renewed at the end of their terms. And here is the solution. We are looking for the probability that x, which is a percentage of policies, is greater than or equal to 80, and y, also a percentage, is greater than or equal to 80. That's the same as 1 minus the probability that x is less than 80 or y is less than 80. Now, the probability of a union of two sets is the probability of the first one plus probability of the second one minus the probability of their intersection. So this is equal to a probability that x is less than 80 plus probability that y is less than 80 minus the probability that x is less than 80 and y is less than 80. And the reason why we're switching to this is because these probabilities are calculated using the cumulative distribution function, while the probability that x is greater than or equal to something and y is greater than or equal to something cannot be easily established. Well, it can be through this way, but it's not directly given by those two probabilities, and not directly given, or the probability of intersection is not directly given by the cumulative distribution function. So we're just switching it to be in the form that lets us use the cumulative distribution function to calculate it. So this is equal to 1 minus f of 80, 100 plus f of 180 minus f of 80, 80. And by the way, 100 is there because that's the highest possible value for y. Y doesn't go beyond that. And this is equal to 1 minus 80 times 100 times 80 plus 100 over 2 million plus 100 times 80 times 100 plus 80 divided by 2 million, and minus 80 times 80 times 80 plus 80 over 2 million. And then that's equal to, after you cancel out some things, it becomes 1 minus 8 times 18 over 200 plus 8 times 18 over 200 minus 8 times 8 times 16 over 2000. That's equal to, well, 1 minus 180 over 125 minus 64 over 125, or 1 minus 116 over 125, or 9 over 125, which is 0.072. That's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.